Hello students, welcome to our channel. I am Ashok Kumar, Assistant Professor, Civil, Jai Shri Ram Engineering College. We are going to see the lecture related to Foundation Engineering. In foundation engineering second unit, so the important topic is classification of foundation. So now first thing is we have to know what is meant by foundation. So the foundation is the structure to transmit all the loads from the superstructure to the soil. Okay, so every structure, the finally load will be transferred to the soil. So taken as a frame structure or load bearing structure, any structure, so the live load will be transmitted to the slab. Okay, so slab load will be transferred to the beam. So the beam load will be transmitted to the column. Okay, so column load will be transferred to the foundation or footing. Okay, so finally the footing load will be transmitted to the soil. Okay, so the soil should capable enough to carry all the dead load and the live load. So we know dead load plus live load. Okay, so dead load is the load of the structures. Okay, so the beam having some weight and column also having weight, then footing also having weight. Then live load, so we are the human living in the house or any building, and some materials are there, so furnitures and machineries, everything is there. So these loads is come under the live load and the dead load. So these loads will be transmitted to the soil. Okay, so the soil should be capable enough to carry all the loads. So the load carrying capacity of the soil is called bearing capacity of soil. Okay, so the bearing capacity is the main factor of the soil to design the foundation. Okay, so I think you know the what is meant by foundation. So now we go for the classification of foundation. Okay, so based on the depth we go for two type of foundation, that is shallow foundation, another one is deep foundation. Okay, so whenever the bearing capacity of soil is more, we go for shallow foundation. So shallow foundation is nothing but the foundation is laid at the shallow depth. Okay, so we can take this is the footing. Okay, so this is the ground surface. Okay, so this is the ground level. Okay, so this is the depth of foundation. Okay, so depth of footing or depth of foundation. So this is the width of foundation or width of footing. Okay, so whenever the width of foundation is more than the depth of foundation, that is called the shallow foundation. Okay, so vice versa, the width of foundation is less than the depth of foundation, that is called deep foundation. Okay, so for example, in some cases the bearing capacity of soil is very less. Okay, so in deep depth, so the soil having the enough bearing capacity to carry the load, so in that place, so the foundation is laid at the deep depth. Okay, so that is called deep foundation. So the main foundation in using in the deep foundation is called pile foundation. Okay, so next thing is shallow foundation. In the shallow foundation, two major categories there. One is isolated footing, another one is combined footing. Okay, so everything is based on the column. Okay, for example, we go for square column, so we go for square footing. Okay, so for example, in the top view, so this is the column. Okay, so this is the footing. Okay, so for square column we go for square footing, and if case we provide the rectangular column, we go for rectangular footing. Okay, so for example, we can go for the circular column, we go for circular footing. So this is the this is for economical purpose and as well as the center of gravity. Okay, so if case the square footing, we provide the rectangular column, so the center of gravity will be somewhere other places, so eccentrically loaded will be acting. Okay, so in most cases we go for the perfect center of gravity. Okay, next thing is combined footing. Okay, so the combined footing, so if case the two columns are placed very close to each other, so for example, for this is the one column, so the another one is this second column. So for this column we go for footing like this. Okay, so in this second column we go for footing, provide the footing like this. Okay, so here some overlapping is there. So for this condition we provide the footing for both two columns, so that is a rectangular combined footing. Okay, so another thing is in another case, so there is a big column is there, another small column is there. Okay, so if case we go for rectangle combined footing like this, so the cost of the column will be very high. Okay, so we go for like this is the big column and another one is small column. So here we go for like this. So that is a trapezoidal combined footing. Okay, so these are all the columns. So having the heavy load, so the big column will be provided, and this column having small load, so the small column will be provided. Okay, so next thing is, so if case all the columns provided in the buildings are very close to each other. Okay, so for example there is a 6 column in the building, so every column is closely linked. Okay, so closely placed, so we go for foundation for all the 6 columns, so that is called mat foundation. Okay, so another thing is, if case the bearing capacity of soil is very less and the waterlogged areas, we go for mat foundation. Okay, so in lake areas or in seashores, wherever we can't go for the deep foundation, so in that cases we go for mat foundation. Okay, so another shallow foundation is trap footing. Okay, so for example the distance between two columns is too large. Okay, so the columns will be connected in the top portion using the beam. Okay, but in bottom portion there is no connection, so for that purpose we provide the strap beam, okay, to connect the bottom. Okay, so in the top there is a connection, in bottom there is no connection, so this footing will go this direction, another this footing will go this direction. Okay, so for preventing this movement we provide the strap beam, so that is called strap footing. Another thing is, so if case for the one wall is there, we provide the footing like this, so that is called strip footing or wall foundation. Okay, so in load bearing structure, so there is a footing is there, so in that footing is called strip footing. Okay, so strip footing is mainly provided for the load bearing structures. Okay, so these are all some shallow foundations. So next thing is pile foundation. So the pile foundation is classified into 4 types, that is based on the material, based on the load transfer, and based on the purpose, then based on the installation. So first thing is based on the material. So there is a steel piles, wooden piles and concrete piles. Okay, so the steel piles are mainly used in the steel structures, then wooden piles are used in the temporary structures, then concrete piles, so there is a composite material made up of reinforced concrete, so there is a steel reinforcement in the piles. Okay, so concrete piles are made with the steel reinforcement cage in the bore well. So after that we can fill the bore using the concrete. Okay, so these are the concrete piles. So thing is based on the load transfer. So there is a friction piles, end bearing piles and combined piles are there. So the friction piles, so the load will be transmitted using the friction action. Okay, for example, so this is the pile. Okay, so the load will be transmitted to the side of the soil. Okay, so whenever the bearing capacity of soil is somewhat okay, so we transfer the load into the soil using the surface area. Okay, so in that case we go for friction piles. So in the friction piles, the wall of the piles are very rough. Okay, so then only the soil, the friction between the soil and piles we are very heavy. So next thing is end bearing piles. So in end bearing piles, the load will be transferred to the end of the pile, so not in the surface of the pile. So in that pile, so the surface area is very smooth, so as to reduce the friction between the soil and piles. Okay, so next thing is combined end bearing and friction piles. So the load will be transferred to the surface area as well as end bearing of the piles. Okay, so in the friction pile, so the end bearing will be the 0. So mostly we go for combined end bearing and friction piles. Okay, so in India we go for combined end bearing and friction piles. In some other countries, so like coastal areas, they go for end bearing piles only. So next thing is based on the purpose. So the based on the purpose, we can classify into 3 types, that is load bearing piles, then compaction piles and sheet piles. Okay, so the load bearing piles are very much useful to transmit the load, but the compaction piles are not used as a load transmission. That is mainly used for compacting the soil. Okay, so whenever we go for the soil compaction, we provide the additional reinforcement or additional any materials insert into the soil. So in that purpose we provide the pile as a compaction material. So next thing is seed piles. If case we want to separate any other two materials or any separate the two soils, or we can provide the seepage, that is water seepage, we go for sheet piles. Okay, so the based on the purpose there is a three piles are there, that is load bearing piles, compaction piles and sheet piles. Next thing is based on the installation. So the cast inside pile. So in the cast inside pile, so first we can make the bore hole. Okay, after the bore hole the reinforcement cage will be inserted. After that the concrete will be poured into the bore well. Okay, so that is the cast inside piles. Okay, so next thing is driven piles. So the piles are made in the some other areas or some other industries. After that we transport it to the particular place or site, and after that we can drive using the pile driven techniques. So there is a lot of pile driven techniques is there. So screw piles are there, then single acting hammer is there. So the hammer driven is mainly used to drive the piles. Okay, so in order to find out the bearing capacity of pile, we can use two major formulas. So that is, first one is static formula, the another one is dynamic formula. So in cast inside piles we go for static formulas, and driven piles we go for dynamic formula. Okay, so the static formula is mainly based on the friction and end bearing. So this is a static formula we can use. So this is the group capacity of the pile. So N is the number of pile in a group. So then QUP is individual pile carrying capacity. So now we can use this portion as the surface area. So that is the friction area. Then this pile is this part is known as the pile tip area. Okay, so here this M is aggression factor, C is the cohesion for both tip and surface area. So here the area, surface area, so that is pi into D into L. Okay, so if case, so this is a pile. Okay, so the surface area will be calculated. This is a pi d, and to this length is L. So this is the surface area. So here the Cp is again cohesion, Nc is the bearing capacity factor. Then Ap here the tip of the pile. So in the tip of the pile, so the area of the pile is pi by 4 into d square. Okay, so static formula is mainly based on the static piles, that is the non-displacement piles. Okay, so that is the cast inside piles. Okay, so if case go for dynamic formula, we can use the engineering use formula and Haley's formula. So that formula will be driven piles. Okay, in next video we are going to see the design of foundation. Again we will see next video. Thank you.